350 billion emails are sent every single day, and 45% of them are spam. How does Gmail filter 150 billion spam emails every single day? Here's the challenge we need to solve. We have spam emails on one side, legitimate emails on the other. When a new email arrives, how do we decide which category it belongs to? Step 1. Translate text into mathematics. Every email becomes a list of numbers. Here's a spam email. Look at it carefully. We extract features. How many times does free appear? How many capital letters? Exclamation marks? Is the domain suspicious? This becomes a vector of numbers. Each number represents one feature of the email. Step 2. Each email becomes a point in high-dimensional space. Let's simplify it to 2 dimensions. The x-axis is how many times free appears. The y-axis is the ratio of capital letters. A spam email with lots of free and capital letters lands here, in the top right. A legitimate email with normal language lands here, in the bottom left. 1 email equals 1 point. This is the key insight. Step 3. Humans manually label thousands of emails as spam or legitimate. To create training data, humans once labeled thousands of emails. This only happens once to teach the algorithm. Watch as emails flow through. Spam goes up, legitimate goes down. After this one-time labeling, the algorithm learns. From then on, it's fully automated. No humans needed. Now let's plot this labeled data in feature space. Red points are spam, blue points are legitimate. But why do emails cluster together? Look at this spam cluster. These are lottery scams. You won. Free money. Claim your prize. And here's another spam cluster. These are phishing attacks. Verify your account. Urgent action required. Different types of spam form different clusters. Same label, but different tricks. And legitimate emails cluster in the middle. Normal language, professional tone. The key insight: similar content means similar features, which means nearby points in space. So here's our goal. When a new email arrives, we convert it to a point. Now, is it spam or legitimate? We need to find a rule that separates red points from blue points. Our first attempt: can we draw a straight line to separate them? Let's try. No, look at the problem. Blue points are in the middle, surrounded by red. No straight line can separate them. This is a nonlinear classification problem. We need a curved boundary, not a straight line. Here's where it gets beautiful. Imagine every training email emits an influence field. Like ripples spreading in a pond, each email influences the space around it. This spam email emits influence. Watch the ripples. But exactly how much influence does a point emit? Let's look at the math. The influence follows this formula: e to the power of negative gamma times distance squared. At distance 0, right at the point, the influence is 1, maximum. At distance 1, the influence has dropped to about 0.6. At distance 2, it's down to just 0.14, almost nothing. This beautiful curve is called the Gaussian or RBF kernel. Nearby points have strong influence. Far points have weak influence. The gamma parameter controls how quickly influence fades. Low gamma means wide influence. The curve spreads far. High gamma means narrow, local influence. Only very close points matter. Medium gamma is a balance. This controls how strict or loose your classifier is. But what does this influence actually mean? This spam email is saying, things that look like me are probably spam too. That's what the influence means. It's not positive or negative in a mathematical sense. And this legitimate email is saying, things that look like me are probably legitimate. That's what each training point contributes. Now, every training email emits its influence simultaneously. And here's the key: these influences compete with each other. Now the moment of truth. A new email arrives. Look at this email. Normal sender, professional subject, regular language. Its features: 0 spam words, low caps ratio, normal domain. Because its features are similar to legitimate emails, it lands here, close to the blue cluster. A spammy email with lots of free and caps would land over here instead, near the red cluster. So, is our green email spam or legitimate? Let's calculate. Let's classify this email step by step. Step 1. We calculate the distance from our new email to every training email. Step 2. Using the Gaussian formula, we calculate how much influence each training email has on our new point. We sum up all spam influences, 0.04, and all legitimate influences, 4.87. Step 3. Which influence is stronger? Legitimate influence is higher, Fort 9 beats 0.0. The verdict: this email is classified as legitimate. If we do this calculation for every possible point, we get a beautiful curved boundary. Inside the boundary, legitimate; outside, spam. This curved line perfectly separates our nonlinear data. Now, let's visualize this force field in 3 dimensions. The height represents the influence score. Blue regions where legitimate emails dominate, red regions where spam dominates. The decision boundary is where the surface crosses 0, where the influences are perfectly balanced. Watch as we rotate around this force field landscape. From above, you can see exactly how this 3D surface creates our 2D boundary. This is the beauty of the kernel trick. Each training point emits influence. That influence fades with distance using the Gaussian curve. New points are classified by which type of training data influences them more, and the boundary emerges naturally from this competition. You saw the 3D landscape, but the core intuition is simple: just competing influences. Now, in a real SVM, not every point matters equally. The math automatically selects only a few critical points called support vectors. But this influence picture captures the essence of what kernels do. That's support vector machines with the RBF kernel, the force field intuition. Elegant, isn't it?